Hello and welcome to LFI Educates. In our physics class today, we are going to start chapter 5, grade 11, that is laws of motion. Here a major deletion has taken place because of the lockdown. But in this first video, we'll do a quick recap of the portion which has been deleted. But it is necessary for you to know. You might have studied in lower grades, but we'll just recap it once. These laws of motion, this is taken from a branch of mechanics called dynamics. And as I said already to you earlier, before starting mechanics in chapter 3, the dynamics is the study of motion of objects by going into the cause of its motion, and the cause of motion we call it as force. So first let us see what is force. Force is an agent which tends to change the shape of an object, which tends to make a body to move if it is at rest, which tends a moving body to stop, which can change even the direction of a moving object. That agent we call it as force. And that is all about your definition for force. Now, the next term you'll have to know is about inertia. We say inertia is an inherent property of an object to remain at rest if it is at rest, and to remain in motion if it is in motion. This is a characteristic tendency of a body. If an object is at rest, it will be willing to remain like that only at rest. That inherent property we call it as inertia. Or if a body is in motion, it does not want to stop, it wants to continue to move. So that inherent property we call it as inertia. There are three types of inertia. The first one we call it as inertia of rest. When we say inertia of rest, the tendency of an object to remain in the state of rest, does not want to move from there. That inherent property we call it as inertia of rest. Then you have inertia of motion. If an object is in motion, it has a tendency to keep on moving, doesn't want to stop. That inherent property we call it as inertia of motion. And the third one we call it as inertia of direction. The property of a body to change the direction by itself, that property we call it as inertia of direction. So there are three types of inertia, and the main factor what measures inertia is mass. Mass decides the inertia of a body. Suppose a massive stone is there, suppose lying on the ground. To move this body, massive stone, if I say the mass is mom. Mass is mom. If the mass is mom, to make the body to move, you require large force. So the tendency of the body or the tendency of the massive stone to remain at rest, that is your inertia of rest, is decided by its mass. It is decided by its mass. If you take the other example for motion, if a heavy object comes towards you, to stop it, you require large force. So because of the mass of the body, the inertia of moving will be more. Tendency of moving will be more. That we call it as inertia of motion, and that is decided by the mass of the object. Now, Galileo gave the law of inertia. He was the first person to give the law of inertia, said like this: a body at rest wants to be at rest, and a body in motion wants to continue to move until and unless an external force is applied. Some force is required to make a body to move if it is at rest, and to make a body to stop if it is in motion. If an object is coming in motion, to stop the body, it requires some force. Then only we can stop it. That law we call it as law of inertia. It was given by Galileo Galilei. Now, this law of inertia, by taking into account, Newton gave the three laws of motion. Newton's laws of motion. He took the law of inertia, along with that he gave two more laws to complete the laws of motion. The first law is the law that was given by Galileo. The same thing, Newton's first law of motion says the same thing: a body at rest will be at rest, and a body in motion will be in motion unless and until an external force is applied to it. That means if a body is at rest, you have to apply force to make it to move, and a body in motion, you have to apply force to stop it. Force will make the body to move, and force will make the body to stop. That is your Newton's first law of motion. Now the second law of motion, to explain, he introduced a term called momentum. Momentum is the quantity of motion that is contained in a moving body. If a body is in motion, the quantity, how much quantity of motion the moving body possesses, we measure with the help of this term called momentum. Mathematically, momentum generally we write it as small letter p. P is equal to m into v. Multiplying the mass and velocity of an object, we can find out its momentum. Mathematically we can represent like this: m into v. And here momentum, what we are discussing is about linear momentum. It's about linear momentum. When the body is moving in a straight path, that time we take the momentum as, we call it as linear momentum. Sometimes simply we call it as momentum, because when you study rotational motion, you are going to learn one more momentum. That momentum we call it as angular momentum. That is for rigid bodies, solid bodies, like your fan. Suppose this is your fan. These are the blades. When the fan is in motion, it will rotate about its axis. In the same place, it will keep on rotating about its axis. That time, the momentum possessed by a solid object or a rigid object, we will learn about angular momentum. We will learn in chapter 7. When we discuss about linear momentum, we need to be careful. Mass and velocity, you cannot take variable at the same time. If mass is constant, velocity will take it as a variable. Like suppose a bullet I have in one of my hand. This is the bullet, suppose, and this is a gun. Inside the gun also there is one bullet. Then mass is equal, so mass is constant. But if I throw the bullet like this, and if I shoot it with the gun, the velocity in the gun, the bullet velocity will increase, and in this case the velocity will be less if I throw, which will create more impact on the target. Then you will surely say that the bullet which I am hitting from the gun, that will create more impact, so the momentum will be more. So in that case, we have seen that mass was constant and velocity was changing. So velocity will decide whose momentum will be more. Like that, if I take velocity constant, velocity is same, and this time mass is changing. If suppose I take a cricket ball and a shuttlecock, and if I throw like this with the same velocity, then we all know that cricket ball will hurt us more because of its mass. Mass is more, then automatically momentum will be more. Linear momentum will be more. So out of these two, one you have to keep constant. Constant means you have to keep same, and then you'll check the velocity, whose velocity is more and whose velocity is less. If velocity is more, momentum will be more. If velocity is less, momentum will be less. And if velocity is kept constant, and mass is changing, then you have to see whose mass is more. And if mass is less, momentum will be less. The SI unit of linear momentum is kg meter per second. And the dimensional formula, as you know how to write the dimensional formula of momentum, kg means mass 1, length 1, time is downside, power is 1. If you take it up, it will become -1. This will be your dimensional formula for linear momentum. After Newton introducing this linear momentum, then he gave his second law of motion. And Newton's second law of motion is called the real law of motion because it contains both the first law as well as it contains the third law. Let us see what is Newton's second law of motion. Newton's second law of motion says like this: the rate of change in momentum, dp/dt, change in momentum, final momentum minus initial momentum, divided by change in time, final time minus initial time, dp/dt is directly proportional to the applied force. You can write like this: directly proportional to the applied force. So if the rate of change in momentum is more, the force applied will be more. If the change in momentum is less, the force applied will be less. If the change in time is more, force will be less. If the change in time is less, force will be more. That's what it says. From this, Newton's second law of motion, we can come to this conclusion: F is proportional to change in momentum, right? P2 minus P1 divided by change in time interval. Let us say it as T. So F we write here equal to remove the proportional sign, the constant term we use there is K. The value of K is 1 in SI unit. Final momentum, mass into final velocity. Initial momentum, mass into initial velocity divided by change in time. F is equal to K M, if you take common, V minus U divided by T. And change in velocity with respect to time, we call it as acceleration. V minus U by T, we call it as acceleration. In SI unit or in SI system, K value is equal to 1. So F is equal to M into A. So Newton's second law of motion gives us the formula to calculate force. This is a very important formula that everybody should know. Force to calculate, we use this formula mass into acceleration. From where do we get? We get from Newton's second law of motion. So Newton's first law of motion defines force. Newton's second law of motion gives us a formula to calculate force. How to calculate force. Now let us see about the third law of motion. When two bodies, suppose A and B, are in contact with each other, suppose this is body A and this is body B. It was moving in this direction from left to right, and body B was moving from right to left. Suppose they are coming and hitting each other. When they are in contact, then the action and reaction, here action and reaction with both are forces. Action is also force, reaction is also a force. Force exerted by first body on the second body, force exerted by A on body B will be equal to force exerted by body B on body A. And in this case, both are in opposite direction. You can see very clearly. One is going towards the right side, one is coming towards the left. So one will be given with a negative sign. If I use quantity, vector form of the right, an arrowhead will come. Here also the same thing. Everywhere you can put wherever it is a vector. By now you know what are vector quantities. So this is your Newton's third law of motion. Based on this law of motion, rocket is launched. That you know, when the gases are burnt, the fumes that comes out from the gases, at what velocity will come down? With that velocity the rocket will go in the upward direction. Then we can walk on the road because of this Newton's third law of motion. When we apply force with the help of our leg on the ground, we are pushing the ground backside. The ground is pushing us in the forward direction. So that is also an example of Newton's third law of motion. These things you'll be knowing by now. And the next thing, after learning these three laws of motion, will come the term called impulse. Or we call it as impulsive force. Impulsive force. Impulse is a large force. Impulse, when we say, it's a large force that acts for a short duration of time. It is measured as the product of force and time. It is measured as the product of force and time. When a large force acts for a short duration of time, like suppose you are playing cricket with a bat, when the bowler is hitting the ball, you are hitting, when the bowler is bowling, you are hitting the ball with the help of your bat. The ball and the bat comes in contact only for a short duration of time, but with large force, because you are hitting it very hard. Then the impact, we call it as impulse. We call it as impulse. Or it can be like this. Suppose a hammer is there in your hand. This is a wooden block. One nail is there. Then while hitting the nail with the hammer comes in contact with the nail for a short duration of time. But with a large force you will have to hit so that the nail goes inside the wooden block. So in that case also we said that we have applied impulse. Force that acts for a short duration of time, we call it as impulse. Impulse or impulsive force also we can say. Force, as you know, it is mass into acceleration. From Newton's second law of motion, we know the formula. This is time. Mass, acceleration is v minus u divided by t into here t. If you cancel it, you get mv minus mu, which you call it as final momentum minus initial momentum. Difference between final to initial we call it as change in momentum. So you can even define impulse like this. A change in momentum we call it as impulse. Change in momentum we call it as impulse. Impulse and momentum have the same unit, that is kg meter per second. Impulse also the unit is kg meter per second. Both possesses the same unit and it has same dimensional formula as well. And what is your dimensional formula? Then as we have done earlier, mass, length and time power minus 1. This is your dimensional formula for impulse. Up to here you don't have to study for your exam purpose. Just you should know and keep it. From the next topic onwards, you will be writing pen and paper test, or what we call it as exam. For exam you can prepare. Thank you and have a nice day.